Hello, ladies and gentlemen. Today we're going to add on some area formulas on your formula sheet. We're going to be talking about areas of trapezoids, rhombuses, and kites. So we're going to need to add, like I said, add some formulas to your formula sheet, as well as take a few examples for notes into your notebook, okay? So you need a calculator for sure today, as well as something to write with. The very first formula we want to get into our formula sheet here, or understand, is the formula for an area of a trapezoid. So the area of a trapezoid equals 1/2 h, which stands for height, times base 1 plus base 2 added together there. So notice how B1 and B2 are added together, and if you remember from our properties of trapezoids, it doesn't matter which one you call base 1 and base 2, as long as you identify those two as the bases, the ones that are the parallel sides. And obviously the height labeled in this picture here, if you want to draw that picture on your formula sheet, that would be a good thing. The picture is labeling a height straight up and down with the 90-degree corner there. That's important. The height could be on the edge there. It could be in the middle here. It could be over to the side over here. It doesn't matter, but that height needs to be straight up and down. So this is the formula for areas of trapezoids. Let's take a look at one example that we need to get into your notes. This is a chest of drawers, okay? So like a dresser. And the front is a trapezoid as shown. So if I was going to sketch this in my notes, you don't have to draw the dresser, okay? But draw that little trapezoid that you see here. We have a 12 on top, 12 inches, 18 inches on the bottom there, 20 inches, looks like that's straight up and down on the inside. So we need to find the area of the front of this dresser. Maybe we're going to paint it, maybe we're going to put wallpaper on the drawers, make it fancy, who knows? Okay, we need to find the area. So to do that, we're going to use the trapezoid formula, the area for trapezoid. So it's area equals 1/2 the height, base 1 plus base 2. According to the picture here, so we're going to try to find the area. According to the picture, we're going to do 1/2 height. How tall is this trapezoid? If you look at the picture, 20 is a straight up and down height, so we're going to use 20 as the height there. And then B1 plus B2. So I'm going to go ahead and plug in my bases. One is 12 and one is 18. So now if I was going to calculate this or start calculating this, you might start here with these parentheses. 12 plus 18 is 30. So we have 1/2 times 20 times 30. Okay, 1/2 times 20 would be 10. And then 10 times 30 makes 300. So the area of this dresser here, or the front of this dresser, is 300, and now let's remember our units, square inches, okay? 300 square inches. So that's how we would use that area formula for a trapezoid. We would plug in the numbers we have, we would go ahead and calculate that. You can type in calculator at any point if you want to. I just modeled that by doing it by hand. So now let's look at a couple other formulas. Area of a rhombus, ladies and gentlemen. A equals 1/2 D1 and D2. Key thing to note, and maybe draw in your picture, okay, or draw in your formula sheet, is diagonals are the D's. So we need to know diagonal 1 and diagonal 2's measurements. Diagonal 1 would be one corner to another. That's on this outside measurement here. Sometimes it's shown on the outside if the shape's really small. And on the inside, this other diagonal measurement. Again, sometimes shown on the outside if the shape is very small and you can't write on the inside. So in a rhombus, we're going to use the diagonals. Those diagonals would be important. And area of a kite can also be calculated using that same formula. 1/2 diagonal 1 times diagonal 2. Okay, once you get those drawn in your notes, we're going to take or drawn on your formula sheet and filled in on your formula sheet, we're going to take a look at a couple in your notes. So let's find the area of the rhombus or the kite. So this first one, go ahead and draw him in your notes. What is this shape? This shape is a kite. So if I was going to find the area of this kite here, how would I go about doing that? Well, I'd use the area formula for kites. Area equals 1/2 diagonal 1, diagonal 2. Now what's happening here is all of these numbers are being multiplied. There's no adding signs in there. They're all being multiplied times each other. So 1/2 I know how to do that. That's 0.5 times diagonal 1. Diagonal 1 is a corner-to-corner measurement all the way across the shape. So from here to here. How long is it across that kite? That'd be 9 plus 5 all the way across. That would be 14. So diagonal 1, I'd use 14 for that measurement, or diagonal 2, it doesn't matter. And now if I go the other direction, diagonal 2, corner to corner, here to here, how long is that? Well, I only see a 4 right here, and then I got to ask myself, would this be different or would it be the same? And if you remember your properties of a kite, you would recognize that that is also going to be 4. So all the way across that second diagonal, 4 plus 4 makes 8. So my two diagonal measurements are 14 and 8. And now if I go ahead and calculate that, 1/2 times 14 times 8, 1/2 times 14 is 7, times 8 makes 56. So the area of my kite would be 56 square units. Now let's take a look at another example. What about this one? This one is a picture of a rhombus. I can tell because all of the sides are marked congruent there. So same formula would apply. Area equals 1/2 diagonal 1 times diagonal 2. So now we will find out those diagonal measurements across my rhombus here, all the way across. 2.7 here. If you remember your properties of rhombus, 2.7 there. If I add those together, that's 5.4 across my first diagonal. Now doing second diagonal across my shape, all the way across there, that's 1.4 plus 1.4, 2.8. And so now typing in my calculator, 1/2 times 5.4. Okay, that's 2.7 times 2.8 is final answer 7.56 units squared. So there's my final area. Okay, so using those diagonals, key thing to remember, make sure you're going all the way across that shape. Okay, make sure you're using the whole diagonal. And now we're going to solve for x in a couple examples here. So go ahead and write this one in your notes. This time we're given the area is 300 meters squared, so 300 square meters. And we're going to try to find out how long it is in one area or one aspect here of our rhombus. So this is a rhombus, I can tell because all of the sides are marked the same. And we will go ahead and set up the area formula for a rhombus. So we're going to do 1/2 diagonal 1 times diagonal 2. And now if I plug in numbers, I know that the area was given to me to be 300, given right here. So I'm going to plug that in where the A is. This time I'm not trying to find the area, I'm trying to find a missing dimension using the area. And now diagonal 1, 15 here, 15 more, all the way across 30. So 1/2 times 30, and now diagonal 2. Diagonal 2 is labeled with an X here, and that would be another X there. So all the way across would be 2x. So now if I look at my equation and I'm wondering, how can I solve for x? This involves us recognizing how to undo certain things. Now if you wanted to, you could multiply your 1/2 times 30 and make it 15. And we still have 2x right here. Okay, and then you could take 15 times 2x, which would make it 30x. And then we could divide by 30. X equals 10. So I know my missing measurement is 10 meters. That's one way to do it. Some of you may have thought, how can I undo these things to try to get the 2x alone and then I can divide by 2? Certainly you can divide by the 30, you can multiply by 2, the reciprocal of 1/2. Whatever algebra steps you need to do to get that x alone, I want you to do those things, okay? So let's take a look at another example where we're solving for a missing dimension. This is the area of a trapezoid here, okay? Area of a trapezoid equals 39 centimeters squared. We see an x on that picture. We need to solve for it. So let's set up our area formula for a trapezoid. Remember that one is 1/2 height base 1 plus base 2. So area equals 1/2 height, which in this case is 6, and then some parentheses. I always put parentheses around my 6, so I know he's separate from my 1/2 there. And base 1 plus base 2, x plus 9. X is on a base, 9 is the other base. And now if we were going to go about solving this, we'd want to again plug in, oops, I forgot to plug in my area here. Don't forget that. Area is 39. There we go. Now we can solve that. Now we can try to get the x alone. So if I was going to try to get this x alone, first thing you might do is take 1/2 times 6, which is 3. So you'd have 3 times x plus 9 equals 39. And now some of you may see, well, I think I might distribute the 3 times the x plus 9. You can go ahead and do that. No big deal. Or you can decide, you know what, I don't want to do that. I want to get rid of that 3. I want to cancel out that 3 so my x can be more isolated. So if you want to do that, just divide by 3. He's gone, and 39 divided by 3 is 13. And then you'd have x plus 9. And now you can subtract the 9. 13 minus 9 is 4. So x would be 4. 4 what? 4 centimeters. Good. So we can solve for x using those measurements and our area formulas, or we can find the area if we're given all the dimensions. Here's our last one. This one's kind of a crazy one to draw in your notes. Please make sure you're careful to draw it in there with all the markings, and make sure you put your 5 and your 4 on there. That's very important. We need to find the area of this crazy shaded shape here. It's made up of 2 shapes that we know and we should be familiar with, okay? So with that in mind, we got to be careful. We need to make sure that we're recognizing our shapes here and trying to figure out that area. Okay, so first shape you might think about or might see. What are you thinking there? What are you recognizing? What are you noticing? Well, we notice that we have 5s here. You might want to put all these measurements on here. 4 here. And these are all 5s. That might help you identify your shape. Okay, if we were going to go ahead now and try to figure out what we have here in terms of 2 shapes, maybe you recognize this one as one shape together. That would be really great. That would be a plan to find the area of a rhombus and then the area of a parallelogram. Maybe you want to do each of the triangles separate inside there and do 4 different triangle areas. You can do that as well. Okay, this is just one way to get that plan or get that plan moving. So if I'm going to follow my plan and I'm going to do the area of a rhombus plus the area of the parallelogram, we know that the area of a rhombus can be found by 1/2 diagonal 1 times diagonal 2. So for my rhombus, I would need to know how far it is corner to corner here, guys. So 1 diagonal all the way across this end of the rhombus. Well, remember that things with 1 little slash right there is a 4, okay? According to that picture and the way it's labeled. So 4 and 4 make 8. So I know I have 1/2, 8. What about my other diagonal here? What about other corner to corner that doesn't have any numbers on it? Here to here. How would we find out how far that is? Well, if I don't have any numbers on that piece, I'm probably going to have to solve for it or figure it out using other math, using other things we know. And that other thing we know, if I can highlight that a little bit more, is Pythagorean theorem, ladies and gentlemen. You have a right triangle in there, so you need to do 4 squared plus x squared equals 5 squared. And when you solve that, you would get your x to equal 3. So you know that all the way across this diagonal now is 6. See how that Pythagorean theorem becomes very, very useful? We need it often. So now if I was going to finish and find the area of this rhombus, I'd have 1/2 times 8 times 6, giving me an area of 24. Okay? Just for the rhombus. I'm going to add my area of my parallelogram to that. So now if I look over at Mr. Parallelogram over here, running out of colors to highlight. Just the parallelogram. Going to erase the rest so you can see where I'm looking. Parallelogram here. So there's my parallelogram. What does he have for a base right there? Looks like he has a base of 4. Remember, area of the parallelogram is pretty simple. It's base times height. So the base on this one looks like he's a 4. Times. How tall is this parallelogram from base up to the top, straight up like that, straight up to the top. How tall would that be? Remember when we found here to here? It'd be the same measurement. That was 3. So our parallelogram has a height of 3 as well. So base times height would be 12 for the area of my parallelogram. So now if I add those two things together to find my total area, 24 plus 12 makes 36. So my total area would be 36 square units. So this is one approach to finding the area of this crazy yellow shaded in shape. There are others, but as long as at the end you get 36 square units, that's probably a very good way to find that area, whatever your brain sees, whatever you need to do to divide that shape up. Okay, so thank you very much for taking good notes. We'll continue practicing with our area formulas.